right, so we have one more example that we're going to go through and do a formal hypothesis test for a one sample proportion. You're more than welcome to pause the video if you want to try yourself, especially maybe writing out the correct null and alternative. That's a good step. But your whole of these are like multiple choice, but we can sort of write them. You don't rely on just looking at all the choice answers. You want to about what would it look. So the analyst on a morning news program claims that 20% of drivers routinely drive while distracted by their smartphones. A random sample of 126 drivers resulted in 63 that routinely drive while distracted by their smartphones. A statistician happened to be watching this program and decided to conduct a hypothesis test at the alpha equals 0.05 level of significance to determine if this is accurate. So A says we want to write out the correct hypothesis for this test, right? So I'll just start by writing null and alternative, okay? So it claims, right, so, and we're talking about a proportion, so I'll write P. The null should always be equal to, right, and it's claiming 27% of drivers. Now, 27% is a decimal, so 0.27, 0.27. It says, claims that 27% of drivers routinely drive while distracted by their smartphones. So then it says, right, decided to conduct a hypothesis test at the alpha equals 0.05 level of significance to determine if this is accurate. So if it's saying that it claims this, that they're trying to determine, it's not really saying greater than or less than, it's just saying it's not this. So it's going to be not equal to. This is going to be a two-tailed test. Okay. So now we want to find the test statistic. That is our Z. So in order to do this, we'll do this in our calculator. We need a couple of different pieces, right? So we need the random sample, right? So 126, and it says 63 routinely drive. So that's 63 is going to be X. And we know in our calculator it's going to ask for P naught, which is just what's in the null and the alternative, that value there, so 27. So let's go through and find. We'll be able to find part B and part C all in our calculator, sort of all at the same time. So we're going to go through, we're going to hit our stat button, go over to tests. We want the one proportion Z test, so one prop Z. So we're going to enter our value it's sort of claiming, so 0.27. X in our case was 63. N was 126. Our proportion, so it's the not equal to in this case, so we'll highlight that. We'll calculate that. So it looks like Z is going to be, so two decimals, so 5.1, or sorry, 5, I mixed those up, 5.82 would be my test statistic. My p-value, right, if you go down below, so it says round to 4 decimal places. So if I think of where this would be, it's, right, e to the -9. So 3, 4, 5, 6, 7, 8, 6, right, which is roughly, we would say it's roughly 0. It is not exactly 0, but for our purposes, we would say it's 0, right, which is very, very small, meaning if you think that this shows it's really, really far away from the mean. So when we make our decision, we're going to compare our p-value, right, with our alpha. Our alpha was 0.05. So alpha was larger, so we are going to reject the null hypothesis, okay? So as you're going through and doing this, this type of question in your homework, you want to think about what each of these pieces are and then answer, again, sort of the multiple choice that it allows. Okay, so now we're here to our conclusion. So because we reject, we can say, again, there's more than one way you can go about writing it, but we can say there is significant evidence to suggest that the actual proportion of distracted drivers is different than 27%. So sometimes some of the ones on the homework, they'll actually ask you for like to put in the level of significance. So they could say at the 5% level of significance, there is significant evidence, something like that. So you just want to sort of look at how the question is worded. And again, a lot of times it's sort of multiple choice. So because we rejected, we say there is significant evidence. Now we're not saying what it actually is. We just say that it's not, right? It's different than 27% of what, that is what they are claiming.